60-second adventures in astronomy. Number 1, the Big Bang. Just how big was the Big Bang? The idea that the universe is expanding as the result of a single explosion wasn't always universally popular. In fact, the term Big Bang was coined in 1949 by astronomer Fred Hoyle as a way of sarcastically dismissing it. But thanks to Edwin Hubble, we now know our observable universe is expanding. And extrapolating backwards, we can tell that 13.7 billion years ago, it was all compacted into one superdense ball. And this singularity expanded and cooled to become everything in the universe that we see around us. So though the Big Bang involved everything in existence, its beginnings were really quite small. And after measuring the background radiation in the universe, astronomers have worked out that the Big Bang was only around 120 decibels, about the volume of an average rock concert. So while the Big Bang still has a lot to teach us about the universe, we do know, at least to start with, it wasn't particularly big. And it wasn't much of a bang either. "60-second adventures in astronomy. Number 2, supernovae. One of the most mind-blowing events in the universe is the explosion of a star. In 1054 CE, Chinese astronomers spotted one so bright they could see it in daylight. Today, you can still see a cloud of gas and dust from the same explosion, and because a drawing of it looked like a crab, it was called the Crab Nebula. Much like a supercharged lighthouse, the center of the star, now a neutron star, spins 30 times a second, and sends out a beam of radiation. Several thousand of these have been discovered, each about 20 kilometers across, but with a mass similar to the Sun. If we could imagine a cup full of neutron star matter, it would weigh 100 billion tons. But supernovae are more than just impressive bangs. Life-forming elements like carbon and oxygen were created inside stars. And the explosion of the star creates even more elements, like gold and platinum, to create generations of stars and planets, and a variety of attractive ornaments. So in a way, everything is made of stardust. But luckily, it's not all quite as dense as a neutron star. "60-second adventures in astronomy. Number 3, exoplanets. Like fussy holidaymakers looking for a home from home, astronomers are fascinated by finding planets similar to Earth beyond our solar system. But planets outside our solar system, known as exoplanets, are difficult to spot because they get lost in the glare from the star they orbit, like a mosquito flying around a street lamp. So how do you see something that's effectively invisible? Observing the changing appearance of some stars, astronomers found that an exoplanet could be detected by measuring the effect of its gravitational pull on the star it orbits. Some can also be detected if they pass in front of their star, causing its light to dim slightly, like a wink. You can even work out the planet's mass and size from the amount of the star's wobble and the depth of its wink, which gives us a pretty good idea of what it's made of. Some exoplanets may even contain water because they orbit their stars in the Goldilocks zone. Any further away they'd be too cold, any closer too hot. And although hundreds of exoplanets have been discovered, astronomers haven't yet found one that's just like the Earth. Who needs a second home anyway? "60-second adventures in astronomy. Number 4, a day on Mercury. No two planets act exactly the same, whether it's Jupiter spinning in only 10 hours, Venus spinning backwards, or Uranus tilting to one side. But Mercury is particularly strange. It takes nearly 59 Earth days to rotate, which might make for a pretty long day, but at least you'd have time to get things done. But while the days are long on Mercury, the years are relatively short. It travels round the Sun in just 88 Earth days. Now, until 1965, we thought Mercury span exactly once per orbit, which would mean that one side of it was always facing the Sun. If it spanned twice every orbit, its day would be the same length as its year, which would at least make calendars nice and simple. But it actually spins 3 times for every 2 orbits, which means each Mercury day lasts for 2 Mercury years. So while you might get a bit bored waiting for the evening, at least you'd be able to celebrate your birthday twice a day, even if you had to share it with everyone else. "60-second adventures in astronomy. Number 5, the rotating moon. Whenever you look at the moon from Earth, it always looks similar. Different parts are illuminated at different times, but oddly we always see the same features. The moon never turns its back on us, much like the rules of etiquette when you visit the Queen. So does this mean the moon doesn't rotate? Well, no, because then, as it orbited us, we would see first its front, then its left side, and then its rear. What actually happens is that the moon rotates exactly once every orbit, which takes a bit less than a month. So, though you'd see it spinning from an outside perspective, from the Earth we always see the same side. In fact, we didn't get a proper view of the far side of the moon until 1959, thanks to a Soviet space probe. The moon used to spin a lot faster, but over millions of years the gravitational pull or tidal force from the Earth has slowed the moon down. The same thing has happened to most moons of large planets. But it doesn't work both ways, because while the moon is spinning once every orbit, the Earth is rotating about 30 times faster. So from a vantage point on the moon, you'd get to see us from all sides, if you stuck around long enough. "60-second adventures in astronomy. Number 6, life on Mars. For centuries, writers, astronomers and David Bowie have been asking, is there life on Mars? The idea that we're alone in the universe seems incredible, so people have dreamed up all types of alien. We know there aren't any bug-eyed monsters on Mars, but it does have a lot of places where microbes could live. This may inspire a low-budget movie, but crucially, if life on Mars started independently from life on Earth, then it's much more likely that it could also start in other places in the universe. But over billions of years spent with asteroids crashing into them, Earth and Mars have exchanged more pieces of rock than geologists at Christmas. And those rocks could carry microbes from one to the other, meaning any life on Mars could have come from Earth in the first place. So it would tell us nothing about the likelihood of life originating on the planets of other stars. Though it would pose another question. Did life on Mars come from Earth, or did life on Earth originally come from Mars? In which case, Martians could be a lot closer to home than we thought. "60-second adventures in astronomy. Number 7, event horizons. Just what is the point of no return? Karl Schwarzschild was a German physicist who not only served in the First World War, but at the same time managed to work out the exact distance from the centre of a black hole to the point where gravity becomes so strong that even light can't escape. This is the point of no return, also known as the event horizon, because much like the normal horizon, beyond it nothing can be seen. But it's not just black holes that have event horizons. The expansion of the universe is accelerating, meaning the space between distant galaxies and us is expanding so quickly that their light can't travel fast enough ever to reach us. So the whole universe is a bit like an inside-out black hole. And as it carries on expanding, fewer and fewer galaxies will be observable to us as they pass to the other side of the event horizon. And when they're lost from view, that's it. They're not coming back. That's the point of no return. And the whole universe will eventually just... "60-second adventures in astronomy. Number 8, dark matter. What's the matter with dark matter? Fritz Zwicky was a Swiss astronomer who could probably get you 81 points on a triple word score in Scrabble. In the 1930s, he noticed that galaxies within clusters were zooming around far quicker than their mass would logically dictate. So he figured that there must be some extra mass in there, some sort of dark, invisible matter slurping around the universe. He imaginatively called this dark matter. But the problem is trying to prove it, because unlike other dark things, you can see right through this stuff. And this gave Zwicky another idea. According to Einstein's theory of general relativity, the more mass something has, the more it magnifies and distorts objects that you can see through it. So by studying the distortion of distant galaxies, we can calculate that there must be some extra mass between us and them. But because we can't see it, touch it, or weigh it, it's not surprising that we can't figure out exactly what it is. And that's what the matter with dark matter is. It makes up most of the mass in the universe, but when it comes to knowing the details, we're still in the dark. "60-second adventures in astronomy. Number 9, dark energy. Why is the universe expanding?" Albert Einstein was absolutely certain the universe was stable, but he couldn't work out why his snazzy new relativity equations suggested that it was contracting. So Einstein figured space must have an inbuilt tendency to fling itself apart, which would balance out the pull from gravity. This flingy outness got called the cosmological constant and meant the universe could be kept static, which was great, until it was proved by Edwin Hubble that the universe is in fact expanding, and that cosmological constant became what Einstein described as the biggest blunder of my career. Then, in 1998, scientists discovered that the universe was not only expanding, but that expansion was actually getting faster. So either space does have a tendency to fling itself apart, or there must be some other hidden weird stuff in the universe causing it, referred to as dark energy. Astronomers are looking for it right now by measuring tiny kinks in space. And in its simplest form, this dark energy is pretty much a cosmological constant. So Einstein was right all along, apart from the time he said he'd blundered. The big thicko. "60-second adventures in astronomy. Number 10, special relativity. Does time fly when you're having fun? In 1905, Albert Einstein introduced the theory of special relativity, which said that if the speed of light is constant, then people must experience time differently. Which may sound impossible, but Richard Feynman later showed that you can prove it with just lights and mirrors. If you set up 2 mirrors, one of which had a flash bulb and a detector on it, you could build a clock which ticked every time the flash was reflected back to its original source. It would keep time perfectly, though it would make a slightly annoying alarm clock. But if you make this clock go past you very quickly, the light has further to travel, and since light always travels at the same speed, the moving clock runs slower than when it was at rest. So though time might not fly when you're having fun, a moving clock does tick more slowly than the observer's stationary clock. Which may have changed the way we see the universe, but doesn't always make for a good excuse. "60-second adventures in astronomy. Number 11, the Large Hadron Collider. The Large Hadron Collider is a high-energy particle accelerator which is being used to help us understand the origins of the universe. Some people complained that by trying to recreate the Big Bang, the collider could accidentally create another universe, which could make things a bit cramped, or worse still, create a black hole into which we all disappear. But luckily the collider isn't trying to recreate the Big Bang itself, just what happened shortly afterwards, by staging collisions that are continually produced all over the universe quite naturally. Some of these collisions have amazingly confirmed the presence of the mysterious Higgs boson particle. So is it safe? Well, if you stuck your head in it, the needle-thin beam would easily kill any living tissue it passed through. And in 1978, Russian scientist Anatoly Bugorsky accidentally got shot through the head by a proton beam, and even though he luckily survived, it wasn't good for him. So it's probably best not to stick your head into a hadron collider of any size, because at the very least you'd have to live with the fact that you'll forever be known as that guy who stuck his head in the Large Hadron Collider. 60-second adventures in astronomy, number 12, black holes. DIY tip 34, how do you make yourself a black hole? A black hole occurs when something has so much mass in such a small space that nothing can escape its gravitational pull, not even light. In 1931, Subramanian Chandrasekhar calculated that if a star is big enough, when its fuel runs out, there is nothing to stop gravity from making its core collapse to create a black hole. Unfortunately for Chandrasekhar, his contemporaries, like Sir Arthur Eddington, just didn't believe him. But it turns out he was right, and in 1983 he eventually won a Nobel Prize for it. So if a star is big enough to begin with, when it collapses it becomes so dense that its gravitational pull won't let objects or light escape. In fact, you'd make a black hole if you crushed any object until it was small and dense enough. But you don't always have to crush something to make a black hole. The bigger one is, the less dense it needs to be. So you could make one out of tap water, though the required amount will fill the space between the Sun and Jupiter, and sadly there's not enough water in the galaxy for that. So for you DIY enthusiasts, you'll probably have to order it in specially.